Welcome, everyone. I'm BK. I'm the director of the Maintenance Institute at the Pennsylvania Recreation and Park Society, and I am here with a collaboration amongst Penn State Extension, Rutgers, as well as Rails to Trails and the Lackawanna Heritage Trail. We are working on a topic that hits many different audiences, and so that's why we have found there's folks here from Public Works, there's folks here from the trail world, and there's folks here from the arborists kind of side of things. So we've hit a sweet spot when we're going to be talking about roots and trees and what does that do within transportation corridors. So we're going to be passing things around. I'm going to hand things off to Tom Sexton from the Rail to Trails Conservancy to open up with some opening thoughts.
Thank you, Brian and Jason and Vinny, for your time on this important issue. America's trail managers do a great job maintaining their trails, often with limited resources. However, the issue of trails and tree roots is one that hasn't gotten enough attention over my 3+ decades with the Conservancy. Far too many asphalt and concrete multi-purpose trails have had to be partially or totally reconstructed because tree roots are not given adequate attention during planning, design, and construction. The result has been a bumpy ride for users, and since it occurs so frequently, what is really construction has been incorrectly lumped into the definition of maintenance, and thus increasing the perceived cost of trails. The other issue that distorts trail asphalt costs are, given the lack of research and information on trail asphalt dynamics, is the incorrect use of road asphalt standards for trails. Those are two different things. The situation is taking away funding from new trails and maybe funding for amenities or programs you would like to do on your trail. And of course, time that you could be using on other maintenance tasks. Also, these high perceived costs give leverage to those who would be against trails or their expansion. Further, there's another decision point that comes before all this, and that before you choose your surface, that is whether to use asphalt or concrete or a crushed stone. I don't believe enough analysis goes into this determination. Depending on whether a DNR or DOT is funding the project, or if your bicycling or trail nonprofit is championing the project, usually determines this most important answer. Plus, there shouldn't just be two options, either paving or a crushed stone for the entire trail. A trail can have both hard and soft surfaces and not lose its continuity or the primary user it seeks to serve, while balancing many other direct factors, including the merits of creating another impervious heat gathering surface. I think probably those last few things give us some topics to ensure a longer webinar series, hopefully. Finally, with the recent unprecedented gain in construction and maintenance trail funding from the federal government, now is the time to build it right from the start and retrofit where needed. Our speakers today can give you the answers. It might cost a little more upfront, but even in the midterm costs and time is less, and the results are better experience for all. So I think I'm handing it off to Vinny next, right?
Yep, I'm up.
All right. Thank you.
So I'll preface this with saying, I'm an urban forester, certified arborist. I work for Extension, and I've been working with trees and sidewalks for probably 30 years. So now, our adjustment here is now trees and trails. And I know when Tom asked and BK asked, would we get involved in this? I reached out to Dr. Jason Grabowski from Rutgers to also get involved. Jason's done a tremendous amount of research on structural soils and roots. So I think we've got a good team here. I don't know if we have all the answers for you. What I am also going to share with you is please put your name and organization in the chat so we know where you're coming from. Keep your mics muted if you can, and we're going to take questions at the end. So towards the end, if you can put some questions in the chat, that would help us. So we're going to smoothly go through our slides and then take some questions. So Jason, the next slide, I think. So both Rutgers and Extension, and by the way, there are land grant universities across the United States. Extension is a wonderful resource, so hopefully you all know something about Extension and are able to reach out to Extension. Not going to tell you there's urban foresters and arborists in every Extension office, but we are there as a resource for you. Next slide. Okay, so we've got our first poll question. We just want to know who you are. I think when we advertised this and there was no formal registration, so if we could launch that poll, just let us know who you are. Are you a private citizen or volunteer? Are you part of a nonprofit staff, maybe a trails group? Are you part of local or county government, state and federal government? Or are you with the private sector? Are you a consultant? So if you're, I don't know, BK, are they filling out are we seeing?
We're at 83% right
okay.
now. It's going up.
Okay.
Once we get around 95 or so, I'll end it.
All right.
90, 91.
So yeah, let's show everyone where we're all from. How's that? Can you launch? Yeah, there you go. So a lot of county and local government, but actually a really good mix here. There's as Tom said, there are lots of citizen volunteer groups working on trails. So good mix. Thank you for that. Our next poll question, we really want to know, what types of trails do you manage? Are they urban, suburban trails? Are they rail trails, historic cultural trails, rural wilderness trails? Probably going to get fewer of those if, we're talking roots and asphalt. River trails, multi-use trails, ATV snowmobile trails, mountain bike trails, through hike trails, or National Park Service or state park trail systems. So please let us know what kinds of trails. I think you can choose multiples. So go ahead and click your little heart out and tell us what kind of trails you're working on.
Call now.
We're at about 72% right now. Oh, 70, 80. It's going up quick.
Thank you.
This is like my blood pressure. No, wait, that's only when I'm on the trail. Sorry. Let's launch that. Let's show everyone what we're looking at. A lot of multi-use trails. Yeah, that's what I figured. And urban and suburban is what I figured anyway, because we're talking asphalt, right? So a lot of the urban trails tend to get those paved surfaces. So yeah, so I'm going to turn it over to Jason. Here's our format. We're going to talk quite a bit about roots. So don't worry. We're not going to try to geek out too much on you on roots, but you got to understand tree roots before we do anything with them. Then we're going to get into some solutions. I'm going to chime in here and there. Tom and BK may also, and then we'll get to your questions. So Jason, it's all yours.
Okay, sounds good. Howdy, folks. I'm Jason. I'm at Rutgers University, the New Jersey Ag Experiment Station. So part of my time is cooperative extension. Part of my time is teaching undergraduates and graduate students, and then I do some research as well. So the first thing I want to point out is that we're going to talk a bit about roots, and then we're going to talk about the trails, and then we're going to talk about how we build solutions. But we're going to try to connect the dots as we go along. The first big thing here is different plants build their root systems differently. And if I'm next to a trail, I would rather have roots that grow downward into the soil rather than outward laterally across the soil. So if I'm near a trail, if I can hold a meadow habitat close to the trail, I'm going to be saving myself a little bit of aggravation as far as roots buckling the trail or displacing soil so that I get a unlevel surface. Now, roots in plant communities, they compete for space. So the more I have aggressive downward rooting in a plant community next to the trail, I'm discouraging some tree roots from going horizontally through and getting underneath the trail. Doesn't prevent it, but what we're doing is playing the competition to our favor. Trees, on the other hand, they're very large organisms. They intercept wind, and so they build root systems that hold them up in the wind. Let's see if I can't flip down. And so when we look at a tree root system, we usually use this analogy of a good wine glass on a plate. Number one, if we look at enough trees, that means we're drinking enough wine that we can have a little bit of fun. But ultimately, what we have is a relatively shallow horizontal root system. And that anchors the soil from erosion, but it also is anchoring the tree. So when that canopy intercepts wind, that energy that isn't taken by the tree moving its branches, that gets distributed down to the soil level. And so we're building a mechanical structure underground to hold the tree up. If your tree is too close to the trail, the pavement is going to lose more often than not, because the tree is going to grow to hold itself up in the wind. Now, different tree root structures can be described. Most often, we're talking 85 to 90% of the root system is in the top 12 to 18 inches of soil. And then we get plates that can look heart-shaped. They can have what we call post roots, or we can have shallow plates. In this slide, we have a rather shallow soil with, these are Norway spruce, which are shallow-rooted species. So I probably would not want these really close to a trail because the roots are going to be biased to the surface anyhow. But you can see me there in the upper left corner with Finn the adventure dog. And that is a root plate that is all of 8 inches thick, supporting a tree that was planted in 1934. And so when we think about our trees, it matters what species you're looking at, but it's really about this play of distance. In the lower left, what we have is a crabapple tree growing in a pavement material that was designed to get the roots to grow downward. So we do have some of these technologies. I'm not sure that this is the most appropriate for a trail, but this is how we look at pavement engineering, say for sidewalks or for parking lots.
And Jason, let me just add to that,
Yes.
that last picture. If your soils are wetter, compacted, poorly drained, you're going to get more surface rooting because
Yes.
roots need oxygen and water. So they're going to be even shallower in a compacted soil or a hydric, wetter soil. So just keep that in mind that, roots grow differently in different soils. And that's why that image you just showed of the structural soils, they're growing deeper because there's more space. There's more rooting space for them.
Rooting space, air, and the water is draining downward. Roots will follow water. That's so true. Roots are going to anchor that tree in the soil, but they're also going to fuse with same species and build root networks through the forest edge. So if you have a trail by the forest edge, it gives us some opportunities and some efficiencies as far as where the roots can be and how trees will contribute to each other in their management. When we get close to the trunk of the tree, however, you have lots of roots going into one trunk, and roots are really good at fusing themselves and grafting to themselves. And here we have 8 or 9 roots that have become one composite root. And you can see that the soil is trapped inside the root. When you're close to the trunk, you're going to get more damage to pavement because these roots are using it's just raw mechanics. This larger root is able to translate load differently. And so when we're close to a trunk, we're playing a mechanics game with the tree, to the point where we know that trees grow, the root grows more upward than downward when they're close to the tree. By the time we get a few feet out, they tend to become rope-like. And this zone of rapid taper is from the trunk to a couple of meters away from the tree, going from really large roots that will blow apart your pavement to more rope-like roots that we can manage along with pavement. So it's really a distance game, and we can bias that trajectory by having the right meadow communities immediately adjacent to the trail. Now, we've been playing this for a while. Superstorm Sandy hit, and we looked at we looked at 126 trees that were blown over by the wind. And this is the data. I'm not going to show you a lot of data, but this is really important. Almost all of the roots on the edge where we have a wind-thrown tree, they're about 1 inch to 1.5 inches in diameter. Okay, that's where the energy moving through the root is so high that the roots literally pop, and that's when the tree flips over from a wind throw. And we notice on the bottom graph there, maple roots tend to break when they're smaller. The oak roots tend to break when they're a little bit larger. So we know that there are species and genus differences here, but basically we're looking at about 1 inch roots. Where do we see that break? If we look at this plot right here, you can see that as you get bigger trunks, you have to stay further away from the tree. And what we're measuring is where those roots broke, which is important to you because this is where the trail gets uplifted when the tree falls over. If we look at that closely, what it tends to do is follow this line. These stars are from the data in New Jersey. This graph is from spruce trees in North Germany. Okay, wide difference in plants, wide geography difference. This is really a structural physics problem. This is not a biology problem. So the short information answer, stay 10 feet away from the tree, and you're probably going to be lowering both the size of the roots to a smaller size, and if the tree flips, it's not destroying the trail. And it gives you a 10-foot buffer to manage a different vegetation for the aesthetics of the trail. We get too close, we get pavement buckling. This is a redwood. If you're not familiar with redwoods, they get big. They get really big. And having them, in this case, about 2 feet away from the trail, even a rather young tree is able to start buckling the asphalt in this particular trail. Vinny, we good with that?
Yeah, I think the only concern would be, when we're going to talk about practices of root pruning, and this would be one of those concerns of how close do we get to this tree to root prune it. When it's young, it's certainly more adaptable to that root pruning. As it gets older, we would be concerned about destabilizing that tree.
Exactly.
And that's what we don't want to do. So, I look at this and say, maybe can we shift the trail? If we're going to keep the tree, can we shift the trail and bow the trail around that root possibly? Can we raise the grade of the trail? Are there other things we can do if we're keeping the tree? Because what we don't want you to do is create destabilized, unsafe trees along your trails, because we are going to be talking about cutting roots here in just a little bit.
Yes, we will. And that 10 feet, I want to really hit that hard. The data supports, at least if you get a Superstorm Sandy, that seems to be a really stable number. So make that a good target. It's the best target we have. If you don't use 10 feet, you got nothing. So I encourage 10 feet. The nice thing is we also know that root systems don't grow as circles like they're drawn in the picture books. Here we have a tree on a hill where all of the roots are going off to the right, and the functional root system occurs about 6 feet up on the trunk because of the way the ground is laid. And so we really want to think about the context of where your trail is as well as that distance, but it tells us that we have the ability to train roots away from the trail. And we don't have to necessarily worry about limiting root zones by running the trail, but again, stay 10 feet away so that you can build a good plate to hold the tree up against wind. That's going to be a really important thing to consider. If we're close to a trail, if we have a tree close to a trail, if we cut the roots, what we know will happen as the night follows the day is that, one, you have made an open wound on the tree that you're burying in soil. So all the yeasty beasties in the healthy soil have the ability to attack that root and start root decay. And you don't want that if you can help it. The way we typically talk about this as arborists or tree care professionals, you make clean cuts with clean tools. And so quite often you can make your trench, but then we need to be going through after the trenching and cleaning all of those cuts. That cut will callus over, and then the root primordia are going to shoot out of that root, much like the Hydra in the Tales of Hercules, where you have one root, now you're going to have 12, and they're all going to shoot right where that original root was. So this is not a winning proposal to try to cut your roots as a way out of a damaged scenario. The roots will grow back, and it will completely undo your effort unless you have a provision of space so you can train the roots to go where you want them to go. We typically try to avoid cutting any root greater than 1 inch diameter, which happily is about 10 feet away from the tree. Isn't that nice? So again, let's just, trying to keep it simple. There's your distance. Now a poll question for you. Okay, here we go. What type of surfacing causes primary concern for your maintenance challenges? Is it concrete? Is it asphalt? Is it crushed stone or an aggregate? Or is it dirt and grass? Dun, 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 dun.
At about 70%. All right, answers stop coming in, so we'll stop there.
Okay, what do we got? A lot of asphalt. Okay, you bet you're here we go. We're going right to asphalt. It turns out that a lot of our trails are built like pavements, and I use the word sidewalk here instead of say a roadway, because a roadway is typically done by DOT with super paved technology, which is a multi-layer system that's heavily engineered. When we're doing trails, usually we have that surface, then we have a compacted soil or a compacted base over a compacted soil. And so this is just kind of a drawing that I use when I'm talking about designing soils for parking lot pavements. But what we have is the tree. We have roots that are going to interface with that pavement. Here we have the blockage of a curb, but we have our wearing surface. That's what your bikes or your hikers are on. And then that has to be supported by a strong material. We usually call that a base, if it's a material that we bring in onto the site. If it's just the soil and then we put the asphalt directly on the soil, we just call that a subgrade, and we compact that very heavily. The reason why is if I put a load on the asphalt, that load has to be transferred through that wearing surface to the soil below. Everything is held by the compacted soil underneath your surface. So when we're thinking about trails and trees, you need to pick a surface, and you need to know what is the traffic type, the kind of traffic patterning, and the loading, because quite often asphalt can work, but it's very expensive, and maybe you're over tooling the trail. But it really depends on how much traffic and what the loading is going to be on that trail. To do asphalt surfaces, you do have to compact. And if you do a concrete sidewalk surface, you have to compact. And what we do is we compact it to a magic number. They call it 95 to 98% proctor density. And we'll talk about that in a moment. We put the thin layer of gravel base to level things off, if at all. And then we either pour a concrete with a wire reinforcement, or we can put down that blacktop and roll it out, punch it down. And then we have a surface for our riders and our hikers. Now, the thing is, a lot of times if we use a gravel base, no matter how hard I punch it with a vibratory tamper, there's going to be a lot of airspace. So roots can grow in that. And if roots are close to the pavement, that's what's going to crack your pavement. But let's start with compaction first. When we have a soil and we compact it, we're putting energy into the soil. What does that do? Well, it does not change how many solids you have in the system. And water being incompressible, it doesn't change the water in your system. The only thing that compaction can do is rearrange the solids so that we eliminate air-filled voids. That's all we're doing. It's like squeezing a sponge and getting all the air out of it when it's underwater. That's what compaction does. More to the point, if I compact the soil and then it rains, I've eliminated drainage, so I have very little air in the system, which is good because usually that means that the strength, the bearing strength of that soil goes up and becomes very predictable and reliable, so I can design my pavement surface. That's a really good thing if I'm about the pavement. It's probably not such a good thing if I'm a plant, and that's okay. But the thing is, between that surface of the pavement and that soil, there is a weak zone. It's an interface between two different materials. The root is going to follow that least resistance channel. So you're biasing the roots towards those interfaces between the wearing surface and your base, or between the base and your subsoil.
Hey, Jason, I know I said I wasn't going to do this, but there's a question that came in that said, is there a reason why we can't compact to 80%
Yes,
instead of?
there's a couple of important reasons. One is it's very hard to control for 80%. We usually use 95 because it allows us a 3-point inspection process. We test one section, we test another. If they're close together, we accept the compaction. If they're different, we pick a third one and we go the average of the closest two. And it tells us whether we've compacted enough or not enough. And so from that testing criteria, from an engineering context, we're going to go with something that has a known behavior to support that pavement. If you go 80%, you're going to start getting pumping and rutting depending on the kind of traffic you have. How fast does that happen? Well, we call this a Patterson compaction curve. And what happens is if I go over the site 1, 2, 3 times, I've done about as much damage as I can do to that soil on that day at that moisture content. It comes up very quickly to over 90%. So if I play the game right, I can choose different kinds of compaction on the same soil and change moisture content, and I can predict where is my peak density after passing over the site and putting energy in. Why that matters: if I use heavy equipment, I'm going to have a denser soil. I use light equipment, I'll have less density. I could have overweight chickadees jumping up and down on the soil and create a curve like this. What it tells us is when we're building the road, we pay attention to moisture, and the number of times I hit that soil really has a diminishing return. So all of our compaction equipment is designed to hit 95% density at the right moisture content within 3 passes. So that's why we get to 95. It's just a convenient way for us to have reliable behavior and have equipment designed to get it to a point where it can support the pavement. So hopefully, Vinny, that answers the question.
Yep.
In this picture, here we have a soil that's growing turf. We have an asphalt parking lot, and then we have a compacted soil underneath. We kept planting a tree in here, and the tree kept dying because the soil was so compact, it became a bathtub. Couldn't move the water out of there. When we build something like this, we're going to compact it rather heavily so we can support the surface of the tree, the surface treatment of your trail. The only way to get out of that is to decompact the soil. We've been doing that for a long time. This is the most violent method, but I think one of the more fun methods of decompacting that soil. This is meant as a joke, folks, but this is how we used to deal with it. I love it. What we have found, though, is that if I have a really sandy soil or a gravel matrix like a base of crushed stone, if I can control the size of those stones, even if I compact it as much as I can compact it, even past 95% of my target, I can still have root penetration and air voids, but it has to be over 80% sand. We find that if we're less than 80% sand, by the time you properly compact, most roots do not want to penetrate that soil. So going to some of Tom's comments, if we build things correctly, that helps us. It doesn't avoid the conflict, but it certainly helps us in the management of the conflict. So a lot of it has to do with moisture control when you compact and compaction control and the design of that trail. Otherwise, even if it looks really nice, we start getting bumps where we have roots underneath displacing upward that pavement. If we displace it upward enough, we get tension across the surface of the pavement, and that develops a crack. Once I have a crack, now I have air getting in there, I have water going in there, I have an interface that's artificially weak. Roots are going to blast through that and expand. So once you get the crack, now you're off to the races and the tree is winning.
Hey, Jason.
Yes.
I might add on the left side, there's a photo I took up in Massachusetts, and I wanted to show, and some of you have what's called rail with trail. You have an active railroad near adjacent to it. In this, I was trying to get to the point where there's an invasive species, I forget what it was along the fence line there, but those are very hard to control. And that space between the trail and the rail is often sort of an unmanaged, it could be a foot, but it's really, really a key foot, because in this instant, nobody's really controlling that tree. And the tree may be on both sides. It grows through the fence, and the railroad will say, it's not mine. The trail may say, well, I don't know, but it's especially the invasives, and maybe you can talk to that.
Yeah, my guess is tree of heaven.
Jason. Oh,
Yeah.
okay.
It's probably tree of heaven in that
Okay.
railroad corridor, and they're notorious rooters. You could keep cutting them, and they're going to sprout and root, and yeah.
Well, what's interesting is you look at the rail ballast, you see no weeds. And then you have an asphaltic pavement inches away.
Mhm.
There ought to be a way of building a collaborative agreement, because they're using very powerful pesticide tools, herbicide tools to control their right of way. And all you have to do is increase the nozzle pattern by about 6 inches. That would never happen. And you could even calculate the gallonage per mile and just pay for the overspray and just say, could you just overspray a bit? Maybe that's a way of having a good communication with that rail line. They're maintaining it quite well on their side. This is just really about a spray pattern.
Yeah, or those stems could be treated with a basil bark application, and someone walking that trail with a backpack and basil bark can treat those, and we've got lots of resources on the extension website about how to treat invasives. But yeah, that little strip needs to be you need to control what's growing in there, otherwise the problem keeps coming back, right?
Yeah.
Cutting it alone isn't going to work on tree of heaven.
No, it isn't. And boy, they can eat up a metal chain link fence quite adequately. So it's a multiple problem when it comes, and beware of any tree where the name heaven is in it. I'm just saying, it's irony. Anyhow, so can trees displace pavement? Of course they can. We've seen that. But can we design for it? And the answer is, well, yeah, it's pretty easy. Well, first thing is stay away from the pavement as much as you can. The closer you get to that trunk, the more likely you have thicker roots with an upward trajectory of growth. And that energy, every time that tree flexes its trunk in the wind, is going to put an upward load on that surface. So this is really a distance argument. And if you can move backward from the side and you encourage a different plant community on the edge, you can minimize some of this. But if you don't have that, we have spent time and years growing roots deeper and deeper away from pavement to see if we can get roots and pavement to coexist. And we've done some of that work. I've actually got several papers where we've worked that out. The idea is the further away from the pavement, even if you have a high root load, it spreads out with increasing depth away from the pavement. So if you can't get away from the trail as far as the side, if you can drive the roots deeper, you can buy yourself a lot of time. So a lot of our strategies are going to be about pushing roots, going deeper. And as we look at sidewalks, and this is going to work for trails as well, we're getting more and more sophisticated with finite element modeling, showing how far away from the root from the pavement you have to be based on whether you're asphalt or whether you're concrete. And we're getting some of that data put out there. But how does that help you? Well, number one, we have to think about what are our strategies. First one is accept that you're going to have roots and take a wavier pavement. I mean, what is your usage and what is the demand of your clientele? That's an important question. We shouldn't presume it has to be asphalt until it's proven it has to be asphalt. If we can't accept it, then we have to talk about avoidance and how we keep roots from getting underneath that pavement. If that's still going to be a problem where we accept that there's going to be roots under the pavement, can we thicken the distance between the surface and where the roots are, or drive the roots a little bit deeper? But again, can we shift from an asphalt to a packed stone? That's really a useful question to have. We can direct the root growth. We know we can train roots to go where they need to go. And can we contain them so that they don't impact the trail surface? We could do just blockage. So there's a lot of different things we can do. The first thing I would do is call a professional arborist, unless that's what you already have in hand. Walk the trail, because different trees react differently. And look and say, well, how close is this one to being problematic? Small trees are very different than large trees. So identifying what's coming up will certainly change your management over the long haul. So whenever you can get an arborist walking the trail with you, I think that that's a really solid thing to do.
And Jason, let me add here, prevention early on is going to go a lot better than if your trail already has speed bumps, right?
Yeah.
Because you've got some major roots there that are now lifting the asphalt 2 inches, and they're cracking, just like the images we saw earlier.
Yeah.
If you've already got major cracking, your trail is going to degrade. If we can prevent those roots in that sub base where they want to grow best, you know, if we could do it in design before the trail's built, that's even better. But if you've got some of this, it's time to start early. And I know you're going to go into some more techniques with trenching and root barriers, and a couple of people have already asked about root barriers in the chat. So I'm going to let you keep going and I'll shut up.
Okay. Look at that. Benny, you're clairvoyant. Here we go. So One of the first things we can do is keep roots from getting underneath that wearing surface in the first place. And the idea is you have to cut a trench and then put a barrier, a physical barrier between the root and the pavement. Now, this can be done in design. This can also be done as a retrofit. If it's a retrofit, realize that you may be leaving root system underneath that pavement. And when that degrades and when it decomposes, now you've got a hole where it's not supporting the pavement. So then you do have a longer term problem once the damage has happened. To reiterate what Vinny had just said, if it is a retrofit, you get a trencher, you drive that trench down and you cut a slice and then you drop a barrier into the place.
Yeah, those were, if you back up 1 second, so those trees were planted the season before. Those were new sidewalks. And here was the prevention, and I think you'll see a picture of them later. And there's different root barriers, right? So, and they're really affordable. It's going to add expense to your trail, but they're going to extend the life of your trail. So there's linear barriers that lock together. There's some that come in rolls. You can use a geotextile one with impregnated herbicide in it, a little bit harder to set in place because the top of your root barrier needs to be at the top of your paving. Otherwise, roots tend to jump over things if you put it too deep. So,
Vinny, how often would you do that trenching if you don't have a root barrier? Every couple of years?
Oh, if you didn't, geez.
Yeah, that gets to Hercules and the Hydra. The more you cut it,
just gonna
the faster your return interval, because you're just multiplying your problem.
I think if you're gonna trench, plan to do a root barrier. And even if it's a simple geotextile, if it's the linear deep root barriers that lock together, you've got to do something. You're spending the time trenching, put a barrier in there.
Yeah,
I've even
trenching
seen
is the most expensive.
Does Tarlon, like putting that on the end of the roots, does that help?
I mean, again, we've seen research where even a geotextile, because it's fine mesh, when the roots engage it, they get girdled. The problem is installing it. You really have to pin it in the soil to install it to a depth of a foot, at least a foot, if not 18 inches. So I know Jason's got, I don't want to chew up time. Jason's got some images here of it actually being installed as a retrofit in a park setting.
Yeah, so here we've got damage to an asphalt trail. This is from Deep Roots product website, and this is, I've got to say, the roots are a little bit close to the trail to begin with, but I understand this is design. So what they did is they went through and they actually excavated out, pulled out the trail. They cut a deeper trench and they put an 18-inch deep linear wall. This is a structural plastic wall, and this is in segments. So they just kind of lock them in. It's click and lock technology, just like if you had a floor that you were putting in, like a pergo floor or something. Once they have that in, it's snugged up against the soil on the one side. You can see it in the trench here. And then they backfill, they put the new asphaltic surface on. And when, I'm sorry, let's get there again. When they did that, they pulled all of those decomposing roots out that they cut, so they didn't have cratering later on. And so this would be, you're actually rebuilding the trail, but now you're rebuilding the trail with a wall. And it can last for a good period of time, even in close proximity to the tree. That does nothing to talk about if these trees intercept wind, are they stable? Again, I like that 10-foot rule. I know we don't always get 10 feet, but you can see how this thing may work. Now, the idea here is that you have to dig the trench and then you put it up against your wearing surface. As a retrofit, this has to be sealed up against that concrete. I would suggest using an adhesive so that roots can't simply jump over and back down underneath in between the sidewalk and that wall.
Yeah, Jason, we've even used them as a form So we've set the root barriers and then poured the concrete nowadays.
Yeah,
It
and
takes a
that's-
bit to convince the concrete contractor that they will work, but they work really well. And once the concrete's poured to it, it's there.
Yeah. It's key because what if you do it right, now you've got some longevity. And here's that follow-up picture that Vinny had mentioned where they put it in 1 year after planting the tree. This is the same tree, is it not, Vinny?
Yeah, same trees, 10 years later. And I drive past it. I mean, so root barriers are not foolproof. Mistakes happen. Roots can get under them quickly and then get back into that gravel subbase, but they really do extend the life of that paved surface, and they really do redirect roots. That's what you're doing, is you're just redirecting and blocking roots from growing best in that subbase material that we put down, whether it's asphalt or concrete. We tend to put a subbase down and we create the perfect environment for roots to grow. That's the problem. That's part of our problem, right?
Yeah. The other big problem here is that you've got an 18-inch deep curve. You've got an 18-inch deep barrier. You have the roots in this very narrow lawn range. If the wind ever comes 90 degrees from the street, this tree has no anchorage. So sometimes it's get rid of the tree or change where you're putting the trail. We have data showing where we have the tree, the wall, we've taken the root barrier out, the roots come out here, and the presumption is they're going to come back up to the surface because that's where roots have what they need to grow. But what you're doing is you're hoping they come up at an angle so it does not impact your trail. Again, it's that distance question. If you can get the roots deep, you're doing fine. This is a sand in Florida, but if you have a heavy soil, the roots can go underneath the barrier and they'll run right up the other side and then still displace your pavement. So you really want to get the depth, and you really need to compact this zone so the roots don't get underneath that barrier at the same time, if at all possible in new construction. You can't do it so well in a retrofit. Now, here's a different way of looking at it. And here's a design that a guy named Jim Urban put out years and years ago. It even got published in this infrastructure manual that you see in the center. And this is like an egg carton woven geocomposite. It's just open plastic webbing in a three-dimensional panel wrapped in a geotextile or a weed fabric. We use this for French drains. The thing is, if you build a trench and you run the French drain, the roots will run that channel. The data from Cornell, Susan Day did a study on this. In a compacted glacial till, the roots didn't move 1 millimeter out of that trench. In a sand, it could move several millimeters out of that trench. But the thing is, they will run that weaker interface and they'll run along that channel. So you can train the roots, not by stopping them with a wall, but allowing them to get into that fabric, and then they run that fabric line instead of pushing underneath the pavement. So this is something that there's not a lot of data on, but we do see that it has a positive impact. And so then you would cut your trench, you would clean the cuts of all these roots so that they're decent, clean cuts to eliminate decay getting into your trees. And then you would put in one of these French drain materials. Battle drain comes to mind, and it improves drainage coming off of your trail. If any water gets underneath that wearing surface, it can move out into that French drain. So it actually improves your trail design as much as it does encourages the roots not to go under the trail, but run alongside the trail. So our next poll question. That hole that you saw some white paint. What do you think that paint was for? Was it so that the trenching crew knew how to drive a trencher next to the concrete? Was it chalk dust so that it could show you roots? Was it flour? Because flour in humid weather sticks to the roots better than chalk does. Or is it what we all obviously know it is Is it the line from Cocaine Bear as he was walking away from the scene of the problem? Do we have
No,
any?
people are getting your joke, Jason.
Oh, good, good. Sometimes when you got to explain it, it's a bad thing.
It's skewing the numbers.
Have you
Good.
have you used that on a quiz with your students is what I want to know.
Not yet. I'm road
Okay.
testing it with this audience because
Okay.
we're sophisticated. Yeah, my students should be studying for finals. They shouldn't be watching Cocaine Bear. They can do that over the summer. How'd we
All
do?
right. We've pretty much tapered off, so we're split across the board. We're not really
Wow.
sure.
Yeah. Well, I'm not sure either. It wasn't my picture, but I'm assuming it was to show the roots. It was really just to wake everybody up and say, look, we ought to be trying to have some fun here. It's dense stuff. Now, we do have cases where we have more space and we want the trees to grow in that pavement, in that vegetation zone, and then we have our trail, or in this case, a sidewalk. We do have studies where, well, we do have data where we could put a conduit, train the roots to go to the conduits and shoot it under the trail. And if we do that, the roots are in the conduit. They cannot buckle your trail. And so we would take that French drain material and go conduit to conduit and force the roots to go underneath the pavement in a directed way. This is an expensive way to go. However, if you're painted in a box and it's a historically relevant tree, this is something that we can discuss. There have been some studies on how to build these, but basically you fill the conduit 2/3 of the way filled with the soil. I'd say 92% sand, just a little bit of organic. You train the roots to those conduits. They blow through that nutrient poor material over to the better soil on the other side. But everything's contained. In my mind, I would put one 90 degrees away from the tree and at a 45 and the other 45, so you have 3 prongs to hold that tree in a wind. So this is something that can be tried. Again, there's only a little bit of data on it. It's very expensive to try to test a system like this, but it should be able to work. And again, you could either use a solid barrier like this, or you could use that strip drain. I think the strip drain works because it encourages roots to go in. It has very little support, so it's hard to push in underneath the trail because you don't have support. So they run along that strip drain, but then you put the strip drains into your conduits and you're off to the races. Whenever possible, again, please use that 10-foot buffer. If it's a small tree or shrub, maybe 6 foot. If you really want to go Cadillac, you can actually put cages down in that soil zone, and you can actually build a cantilevered bridge over the root system without touching without impacting the trail itself. This is an expensive option, but I'd be remiss if I didn't point that out. The idea is you dig a big trench. Well, actually, this is the depth of your sidewalk base now. You're going to fill this with uncompacted soil so the roots grow under the pavement, but there's a dead air space of up to 6 inches, and your trail is now on a decking material.
Yeah,
but it is out there.
I'll add, if you're looking for these, you're looking for a soil cell, and they really work well in highly compacted downtown areas where we're trying to grow trees.
Yes.
They are expensive. The expense is in the excavating more than anything.
Yes.
Right. And you're backfilling with good soils. What we're seeing communities get is stormwater credits for using these. So we can direct stormwater into them, or we can put porous paving on top of them, and they work really, really well and do get deeper rooting.
Yeah. And so I think that this is a very useful tool. But if you want this for stormwater, usually you fill it with a stone, a large stone, single size. You don't fill it with soil, so you get more credits. But you can get credits with this. It's a very, very useful tool in your arsenal. It's worth looking into. And Deep Root sells both the linear root barriers and these kinds of cages. So once you get your supplier chain set up, you can get both kinds of products, two different tools, one supplier.
Now, just thinking real quick on an urban setting, and especially with rising temperatures and things, is that kind of a future best practice to recommend? Because now we're reducing the amount of watering we have to go out and do, and after maintenance and things.
That is a totally different seminar about integrating the two and looking at those water budgets. There are 3 different ways of going about it, and that is one of the ways. But I don't think that I would recommend that as your solution, because it's just a tool. And a good tool at that, but there are other ways of going about it as well.
They really have merit when you're rebuilding sidewalks, right? If you're doing a whole streetscape project, you're spending so much money on infrastructure that to incorporate this to get big trees growing, which we know we want in communities for the future, you will get a bigger tree growing in either this or the engineered structural soils than you would in what we typically do is cut a 4x4 opening and plop a tree in, right?
Yeah. Yes. But again, that's a totally different webinar, and we're running a bit long. But we can use structural foams and build distance between the asphalt surface or the concrete surface and the root by putting structural foam in. And we've seen some success with that. Some people will actually also put like a wire mesh in between, so that that seems to give us a little bit more longevity. There's not a lot of data out on these, only 1 or 2 studies. But we do see that they can work. We have some anecdotal evidence of it. We can do what's called slab jacking, where we mill holes into the pavement, and then we pump a grout, and we can re-level pavements, or we can build a ramp up to the root and beyond the root without having that disjunct. And that's more for a concrete surface. And then where we have sets that are displaced, we can grind them out. Okay, this doesn't work so well with our asphalt, but if you have a concrete section, this is a useful thing to think about. Instead of pulling the whole system and relaying it, you may be able to slab jack your way out of it, or grind your way out and buy you some time and budget. You can ramp over the trees by putting a series of piers and just building that bump. Now, if you're doing this for bikes, you've got distances you have to think about. If you have ADA access issues, and if you have to raise it a long ways, you may have other design considerations that you have to look at. Or do you really need that tree that badly? Let's be objective here. Sometimes the tree loses. All right. I don't particularly like it when the tree loses, but that's my bias. But we have to think about that. This is really an absurd situation. And the question is, if the tree is that important, why can't we curve that sidewalk or build something with a little bit less of an angle here so that we don't disrupt the flow of traffic? What is that surface? Is it porous? Is it non-porous? That doesn't necessarily impact trafficability as far as your user. When are they using the trail? If it's buried under snow and you're not plowing it, do you really need to have something that is non-porous? If you are using it during the winter, are you putting salt down? And if so, that's going to negatively impact that plant community. We have to think about when and where are we using this, and what kinds of traffic do we have, not just for the user, but for the management. Because sometimes we have to use portions of trails for emergency access. That's going to have a totally different demand than if it's just something with occasional use. Here we have a packed aggregate in Sydney, Australia. This is on a landfill cap, but they have a public park. And this is just a very fine aggregate that they, with a vibratory compactor, they compacted in place. This is 5 years out from its initial installation. They occasionally rake it. Here I've got an abandoned railway up in central New York. It has not been touched in 30 years, and we still have trafficability on it because railroad ballast bases are really solid things. Now, if I'm riding a bike in wet weather, I might get a trail up my back from mud, but then again, buy a fender for your bike. You know, there's things that we can do and things that the user can do. But now I have a non-sealed natural surface, and this is a really good look and a very low maintenance look. Yes, there's divots, sometimes there's washouts, but I'd rather have that than asphalt when I think about the management scenario driving through a maple wood. Here we have, these come from Vinny. This is a packed stone trail in proximity to a forest, but notice that we have distance between the trees and the trail. And even with a packed stone, we don't have a rough surface from a lot of roots because this gets really heavily compacted. The roots simply turn around and they grow where they have less compaction. So it is something that we can think about.
Yeah, and that is a high use trail. So I think, you know, when things get rutted out, its trail maintenance is as simple as a dump truck with some more crushed stone, some fines, and regrade a little area.
We can use a mastic like a flexi pave, and this can either be asphaltic, it can be rubberized, vulcanized, it can be any number of materials where we take an aggregate and we literally glue the aggregate to a flowable material. Here is one that's made out of decomposed rice hulls on granite, just a granite stone dust with rice hulls, and I get a semi-stable surface that I can use, but it's totally open graded and it's relatively cheap. And even if the roots lift it a little bit, it's not like it's a hard repair. So this is a different natural-ish surface. We can use compressed recycled tires, and we can get rubber unit pavers, and we can reset unit pavers. But again, what are the roots being cut, and what did you do to the stability and the health of the tree? So we don't want people saying, oh, I can just cut big roots and put this in. Yes, that's great for this particular system as a retrofit for the pavement, but it's really not doing the tree any favors. Here you have them bumping out to keep away from the big roots and the cuts. But again, you are so close to that tree, we're well within that magic 10 feet. And please just try to find some distance. Wherever you find distance, it makes your life a lot simpler. Here we have some sidewalks in Canada, and these ones are literally cantilevered over the root system. And we've lifted this by about 2 inches, so we don't have the ADA issues. So you could do a little ramping and a little lifting, and you could get beyond the problem with an existing tree. Here you can see the root right at the surface. That means that soil is really compacted, by the way. So we just lift over and you can bridge over the top. But where is the funding? And I'm going to turn this one over to Tom really quick. We do have a website where you can find some of that stuff. But is there anything that needs to be added, Tom?
I don't think so. We're about 6-7 minutes late. So
Okay.
If you just click on to our that website up there on the right top, you can find really a lot of great sources for funding your trails, but also for funding maintenance. There is a federal funding tool. Please fill that out, and then it will ask you the dynamics of your trail, and then it'll spit out at the end what are the federal programs that you're eligible for. So please do that if you have the time.
Okay, so I know we're a little late. Thanks for your patience, but I'm making time. You guys got a question? Guys and gals have any questions?
I
There
know
was a,
before, whoops, sorry, Vinny, go ahead.
no, there was a question about cement dust. Any experience using cement dust?
Nothing good. Cement dust is ground lime, which drives the pH really high, which changes your mineral nutrition. Most trees do not like being buried in lime. Actually, we used to grind up lime and use that to get rid of bodies.
That's what I was just thinking. I think that's what they do out in the Jersey Pine Barrens, don't they?
No, we just let the Jersey Devil eat them. But anyway,
I do want to add one of our other collaborators on this project, Owen Warosbit from the Lackawanna Heritage Valley Association, has an ongoing project that we're going to be doing this summer. So we've talked about some of the mitigation methods, whether it be root barriers or root redirection. And that's some things we're going to be doing over the summer, and having a little workshop opportunity that people can come out and see some of these projects going. We're going to rent a trencher and do a trench, but then we're also going to use that content to create some how-to videos for folks to see what it takes to do some of these processes and what the best practices are.
Yeah, we're gonna trench and put some root barriers in, and I think, that should be, eye-opening, and maybe we can even start a clock and see, how costly, how much time it takes. And I think everybody's gonna deal with their situations differently based on the resources they have. I know, Tom, you had some pictures of people excavating with a backhoe. I know Jason and I would suggest clean those roots up if that's what you're doing. You asked earlier, how often do you trench? Probably every few years if that's all you're doing, right, Jason?
yeah, you'll have buckling within 3 years in regrowth along, say, sycamore trees.
Yeah.
And again, it's going very species by species. Just going to point out, there goes Finn the Adventure Dog. These are those Norway spruces planted in 1933 in a plantation with the CCC. Just to show you, you can have a trail through those things. When they start flipping, though, that's really going to look interesting.
There was a question that came up on the preventative side here. So
Yes.
looking at when building, especially on a slope or a hillside, is it better to get above the tree root system, or do you want to stay below that tree root system in that kind of situation?
That's it. Part of it's going to depend on the slope, but I would almost rather go below than above.
See, I was thinking the opposite. I was thinking, shouldn't you build up material and maybe leave those roots intact and maybe put some of those conduits? I don't know.
Yeah, I think that, if we're referencing that one slide I had where the roots aren't circular, I think we need to have a blackboard and some time. If that person wants to reach out to me directly offline, we can develop that conversation.
And that is a great caveat so that we can kind of wrap things up and respect everybody's time here. But if you do have further questions and you want the slides and any of those kind of things moving forward, feel free to contact me directly. And I can coordinate all of that communication and make sure everybody gets in touch. I will be the bridge.
Okay,
is there anything that you wanted to add in closing, Tom, Vinny, Jason?
Nope. I look forward to working with you all a little more, and maybe offering some other webinars on more specific angles on this the bigger issue.
And I would add what Tom said earlier: before you put asphalt down, think twice. I mean, my opinion is the trees, the shade, the forest along that trail is probably going to provide you a lot more benefits than whether the trail is crushed stone or asphalt. My opinion, purely.
I just want to remind people, the marketplace sells solutions, but what you want to be doing is looking at strategies and defining the problem well.
That's a great thought and closure.
Well,
All
then,
right,
people, be really good. If not, be bad. Make it worth your time and energy. We'll see you later.
Thank you. Thanks.
Bye,
Thanks,
all.
Brian. Thanks,
Thank
Tom.
you, everyone.
Thanks, Jason, so much.
We look
Bye-bye.
forward to hosting you again in the future.
Okay.